Thanks so much for inviting me. It's a pleasure to get a chance to talk with all of you. Is this okay if I don't hold this? Can you hear me all right in the back? Yes? Great, terrific. So I'm going to talk with you a little bit about some of the potential ethical implications, not just of the BRAIN initiative, but of cognitive neuroscience and as our changing understanding of the brain and potentially self and privacy evolves over time. But I want to talk to you a little bit about the charge for the President's Commission on the Study of Bioethical Issues as well, because we've been charged with the early inquiry about the ethical, legal, and social implications that flow from the BRAIN initiative. And so this is a quote from the charge that came from President Obama to the Commission, which is asking us to consider the potential implications of the discoveries that we expect to flow from the studies of the brain. Questions, for example, relating to privacy, personal agency and moral responsibility for one's actions, questions about stigmatization and discrimination based on neurological measures of intelligence and other traits, and questions about the appropriate use of neuroscience in the criminal justice system, among others. And we've held a number of meetings already at the Bioethics Commission about not just the BRAIN initiative, but neuroscience itself. So we had undertaken earlier a charge on our own to actually look at the implications of emerging neuroscience, and particularly emerging cognitive neuroscience, for understandings of self and privacy. And then in between the BRAIN initiative, as it started to take shape, we were charged with the broader implications of looking at the BRAIN initiative as an early inquiry. But I'm here in my personal capacity, and we're early in that process. And so rather than tell you very much about what the Commission is doing, other than to be happy to field questions about where we are in the process, I'll tell you about some of the things that are shaping some of the inquiries that we are undertaking and some of the things that are influencing my own personal thinking about ways in which the BRAIN initiative might have implications for concepts of self, and I put that in square quotes quite intentionally, and privacy. And just to give you a sense of what I'm going to cover here, I'll start with this kind of concept of rediscovering ourselves, because I think that neuroscience doesn't fundamentally change our conception of self or our understanding of self. It may simply help us rediscover some things we already knew, but gives us confirmation of. It may open up some new venues of inquiry to help us discover and think about issues that we have long since contemplated, and may potentially change the way we think about ourselves with relation to our brain. I'll then turn to a concept that I've studied quite a bit, which is responsibility of selves, and in particular, the implication of neuroscience in the criminal justice system. And this has had some interesting challenges to fundamental concepts of guilt and responsibility, issues about punishment, particularly in the death penalty context, and I'll touch on that briefly and explain some of the ways in which those changes have occurred. And then interesting implications for what it means to predict our future selves, and finally, the concept of continuity in self. But I'll start here with rediscovering ourselves, and I'll start with a bit of a disclaimer, which I think is quite useful, that came from Eric Perens in 2007. So he tells us, whenever we hear that neuroscience threatens our self-conceptions and identities in a uniquely powerful way, we should remember that we once said the same thing about genetics. Moreover, whenever we hear anyone say that neuroimages are thought maps, we should remember that once upon a time, geneticists and genethicists spoke of our genomes as our future diaries. And I think that that's a really useful cautionary tale, because every time we have some new area of science that may help us to understand better information about who we are, about our conscious awareness, about any aspects of humanity, it's easy for people to sensationalize it and to believe that it is going to fundamentally change everything. And I think we've heard that in the past, and it didn't fundamentally change everything when we had the human genome completed. We still are only at the earliest stages of being able to decipher and understand what any of that means. And we're still ourselves. We haven't fundamentally changed very much about who we are. So I want to start with that important caveat, because as I go into some different examples about ways in which I think that neuroscience and the BRAIN initiative may impact conceptions of self, I do so with this backdrop, recognizing that I don't really believe it's going to fundamentally change the world, at least with respect to philosophy, law, and ethics. But nevertheless, cognitive neuroscience is already enabling us to learn about ourselves in some more limited ways, even if it isn't fundamentally changing our very understanding of the relationship between the brain and the mind. And advancing the technologies and discovering the neural circuitry underlying these discoveries could have some important implications. So for example, this depicts a study that is undertaken by Anthony Wagner, who's a leading neuroscientist that many of you will be familiar with at Stanford, looking at the detection of recognition in the brain of faces and rich memories that a person has encountered before. And he concludes that on average, you can be about 75 to 80% accurate in discriminating between whether a person is recognizing the stimulus in front of them as having been encountered in their past versus perceiving that stimulus as being novel. And this raises a question about whether the detection of experiences and the ability to know whether a person recognizes past experiences or faces reveals to us new knowledge about a person that we couldn't have known before. Does it reveal knowledge about ourselves, about our own experiences, and our past experiences that we may not remember? In fact, I did this experiment with Anthony. So a few months ago, he put me into his scanner, and he did this in two separate ways. First, he showed me a series of pictures and said, before you go into the scanner, I just want you to look at these pictures. I had about 2 seconds per picture to look at. And then was put into the scanner and said, just try to see if you remember the faces that you were shown before, or if you don't remember the faces that you were shown before. So went through that. Second round, he said, okay, now I'm going to show you a series of pictures again. This time, when you go into the scanner, if you see a picture that you think you have seen before, try to set up a countermeasure. So try to fool the computer into not knowing whether or not you've seen it before. So try to take a new image and treat it as an old image, and take an old image and treat it as a new image. And all this happened really quite quickly, right? And so I then come out of the scanner, and he has the results already ready for me to be able to go through. I was in there for 2.5 hours. And when I come out, I said, okay, so how did I do? And he said, well, when you were looking at pictures that I told you to accurately report through your brain, whether or not something was old or new, it was about 80% accurate. We were about 80% concordance between what you saw versus what you didn't. When you did countermeasures, it was 50-50. So it went down to no better than chance. That was really interesting to me. And it was interesting to me, it helped me learn something like I am actually a pretty good liar, and it was pretty easy for me to be a pretty good liar. Now, does that give me new knowledge about something I didn't know before? Maybe, maybe not. Already, there are a number of government agencies that are in conversations with Anthony to figure out whether or not this kind of technology could be useful, and how might it be useful. I'll talk about this in a little bit later as I talk about threat detection technologies. But for example, if I'm a criminal suspect, and I claim to have never seen before a co-suspect who you want to know if I've seen before, can you stick me into a scanner and find out by showing me an image of that suspect? Are there any constitutional privacy protections or other types of protections which might safeguard me against the use of such technologies to try to understand my relationship to other suspects that you may want to know? And it isn't just that we can learn about your relationship with other people. We might also learn something, for example, about whether or not you have a disease or you're likely to develop a condition that's presently untreatable, like Alzheimer's disease. And just as genetic predisposition information has changed how some people view themselves, such as a redefinition of their history or through a better understanding of their ancestry, some people will discover, for example, that their brain looks more like a psychopath. And we'll have to incorporate that information into their own self-identity and determine how they're actually going to take that into how they think about themselves. This raises also complex questions about the duty of researchers and clinicians in their duty to look, to discover, and to report on incidental findings that are discovered through neuroscience on research on humans. It also challenges the fundamental conception about how we understand disease. A neurobiological model of disease is quite different than the DSM model that we currently incorporate. And if you look across law, you'll see that the DSM interpretations of disease are pervasive in how we provide disability insurance and how we recognize different categories that are protected in areas like employment discrimination. As we have a neurobiological understanding of disease, those models are likely to be displaced. What are the implications for how we think about individuals, how we think about disease, how we think about classification and categorizations? And it also opens up the possibility of a fundamentally different kind of self-access. So what you're seeing here is an image of Muse, which is a headband that's soon to hit the market. This is one of many different types of consumer-based EEG devices. NeuroSky already has one that's been on the market for quite a while. And these are very simple, single electrode. This one is supposed to be 5 electrode lead devices that purport to be able to do real-time imaging, now EEG-based imaging, of a person's brain. And according to Muse, they claim that they detect 5 different main brainwave bands at any given time, and that because each brainwave band occurs in different proportions, and Muse measures the changes in those proportions, that you may be able to do things like figure out if you're sleepy using the delta waves. Theta waves, which are associated with sleep, very deep relaxation and visualization, are something that you can look at. Alpha waves, which you can use to determine whether or not you're relaxed and calm. Beta waves, which occur when, for example, you're actively thinking or problem solving. Or gamma waves, which occur when involved in higher mental activity and consolidation of information. I have some of these. I think they're really fun to use. I've taken them with me to a number of talks before, and people have bought them for their kids in order to play with at home. They're wireless. They have Bluetooth connectivity to your iPhone, which can be a lot of fun to play with. You can even use it for things like neurofeedback. So you try to get into a mode of meditation, and then you're able to get little birds chirping, which give you feedback, which you then are able to better meditate. But it changes our conception of things like meditation. If I can use a simple neural hack in order to do it, what's the value of meditation? Is it simply a brain state we're trying to achieve, or is it a transcendent state we're trying to achieve? It also raises a different interesting possibility, which is it's wireless. It communicates with your iPhone. It's collecting real-time activity. A number of these different devices promise to upload this information to places like social media, like Facebook. And what can that information reveal about you? And what about the sharing of that information? Is it problematic? Is it concerning to you to have real-time capturing of that information? And it raises for us the question of whether or not individuals should have access to this information. So many of you have probably followed this controversy with 23andMe. It saddens me greatly that as of a couple of days ago, 23andMe has stopped marketing their technology. That is, they're no longer selling their direct-to-consumer genetic testing kits. Why? Because the FDA said that it's a medical device subject to its jurisdiction, and because they didn't receive pre-market approval before starting to market it, for each and every one of their validation claims, they can no longer market it. Well, this raises really fundamental questions about the democratization of science, self-access to technologies and information about ourselves. Is it the case that things like EEG, simple EEG devices which are tracking information, which you can learn things, for example, about your sleep patterns? Some companies claim that you can detect early whether or not you're likely to have an epileptic attack, or if you're going to go into insulin shock. Are those things also medical devices? And if they're medical devices, is the FDA going to exercise jurisdiction and say that individuals can't have access to that until they've gone through pre-market approval? These are interesting questions because on the one side, there's strong intuitions toward paternalism and protection of individuals. On the other hand, there's a strong move toward greater autonomy for individuals and self-access toward information. This raises fundamental questions about whether or not simple information like your brainwave activity is something that will be subject to regulation and beyond your reach before prior approval. Of course, just like you can have access to information, so can others. In fact, researchers in the field of biometrics are tapping into brainwaves to authenticate a driver's ability to be behind a wheel. New research to be published in the International Journal of Biometrics demonstrates how brainwaves can be used for vehicles, in cases, for example, where vehicles are carrying valuable or sensitive information. The idea is to develop a system that can process EEG signals in the alpha-beta bands of the brain's electrical activity, verify the signals it receives against pre-programmed samples from a legitimate driver, and then use that in order to try to authenticate a person. This is just simple biometric information. But what happens when it's not just your iPhone storing your thumbprints, but you're actually using this as real-time feedback to different vehicles and to insurance companies? In fact, this isn't so fanciful. Already a number of insurance companies have started to invest in programs to see whether or not they can get real-time neural monitoring of drivers. And they could use this, for example, like the Mercedes-Benz driver assist system, which can recognize tiny little aberrations in when you move your wheel, the steering wheel of a car, to detect whether or not you're drowsy. And if we can have that real-time monitoring of people who are, for example, truck drivers, they may be far less likely to get into car accidents. Well, that's a wonderful thing, to think that we would have far fewer car accidents. But what does it mean to have real-time brain monitoring activities? For those of you who might be worried about the NSA, for example, who's collecting every piece of email that you've ever written, what happens when they have an enormous store of your brain activity and real-time brain activity? Is this problematic? Should we be concerned about it? And while traditionally there have been ways of knowing about yourself through things like introspection, in ways that no one else can access or know, neuroscience may change that, raising complex questions about whether or not you have a right to mental privacy, to your thoughts, and to your mental processes. Each of us is accustomed to having our thoughts being accessible only to ourselves. And with neuroimaging, the privacy of our innermost thoughts is at least potentially threatened. And there's good reason to doubt that detailed contents of thoughts will ever really be able to be transmitted just by brain scans, and certainly not through EEG. Perhaps enough semantic information will be available to matter, at least in certain cases. So we have to ask about who we want to give access to the information, how much information we want to make widely available. And the BRAIN Initiative is going to generate a huge amount of neural recording information, some of it from humans, most of it from animals, but we'll get to the point where we're actually recording enormous amounts of neural activity. Where are we going to store that information? Who will have access to it? My general view is access restrictions largely fail. So if access restrictions largely fail, we have to ask, what kinds of misuse could this information be put to? And if there is misuse that we're concerned about, are there ways to proactively safeguard ourselves as a society against it? Well, that brings us to the second area, which is responsibility of cells. And here we already see a tremendous amount of activity happening in the legal system, particularly in the criminal justice system, about how we're actually going to reconceptualize the basic concepts and basic institutions we have in society based on neuroscience. Already in the legal system, whether it's in the pretrial process, in the guilt-innocence phase of a criminal case, or in the sentencing phase, we see a tremendous amount of neuroscience showing up in the courtroom. And by neuroscience in courtroom, I mean a criminal defendant coming into the courtroom and saying, my brain made me do it. Well, of course it did, right? What else could have made you do it? And yet, the claim is, my brain made me do it, and the theories of neuroscience and cognitive neuroscience they're developing show us that the very concepts of voluntariness that we used to have are based on a conception and understanding of ourselves that's now outmoded. That it's based on this idea that most of our decision-making arises from conscious determination. And that that idea is one that quickly is going to be challenged, quickly is going to be replaced by an understanding that many things happen through unconscious decision-making, and that our conscious decision-making may have a much smaller role than we imagine. To convict somebody of a criminal offense in the United States, the prosecutor has to prove that the defendant acted voluntarily, with the mental state at the time they committed the criminal offense. But this is a very thin concept in criminal law. We presume that individuals act voluntarily and only allow for a defense that a person acted involuntarily in very narrow circumstances. So you don't often see an automatism or an unconsciousness defense in criminal law. But some attempts to use neuroscience by criminal defendants do exactly that. There's a growing scientific and popular press literature about the role of conscious decision-making versus unconscious decision-making, and it's shown up in quite a few cases. So let me just give you an example. Here's an example of a night of drinking gone terribly wrong. So friends got together, they were drinking after work, and they eventually decided to go home. They decided to take one of their friends home first because he was severely intoxicated. And it was his truck that they had gone out with that evening, so they drove him home first, and they were planning on walking from his house to their own. They drive him home. When they get there, he discovers that he can't get into his house. He's locked out. Inexplicably, he turns around, goes back to the truck. Remember, these are his buddies who he's just gone out drinking with. He reaches into the truck by punching through the glass, drags his friend who's driving out of the truck, and starts to beat him up. His friend manages to get away from him. The other two gather up with him and they start to walk away. Not soon enough, because the friend jumps into the truck. This is the intoxicated friend, jumps into the truck behind the wheel of the car, takes the car and drives it into his friends. He kills one of them by running over him. He severely injures another one. Only one of them managed to get to safety. At his trial, the defense called a neurologist who testified that his offense was consistent with somebody who was in an automatic, unconscious brain state who was taking no purposeful action. The court rejected this defense, finding that the objective evidence showed that he was not unconscious or in any kind of automatic fashion, but voluntary, intentional, and purposeful. He was given a 15-year to life sentence. Fundamentally, though, the problem for him was one of proof. And that's true in many of these cases where the neuroscience just isn't there yet to be able to show what a person's mental state was or what the voluntariness of their actions were at the time of the crime. So consider this colloquy between an expert and a prosecutor, where the prosecutor is saying to the expert who's introduced MRI evidence, in other words, we could have taken 10 people whose MRI looked identical to that of the defendant, and all 10 of them could not be criminals or mentally ill. Is that correct? And the expert says, yes, that's possible. The prosecutor, they could even be from all walks of life. Expert, they could all be lawyers. Funny for me in particular as a lawyer, but this may not be a colloquy that continues when we have much better and discriminating neuroscience. Now, will we ever get to the point where we can describe an action perfectly through neuroscience? Probably not. Will we get to the point where we can describe it better? Probably so. In which case, what happens then? How do we think about the responsibility of a criminal defendant? And you can see here in a study that I've done from 2005 to 2012 that the number of neuroscience claims has steadily increased over time. The different bars just represent the distribution between homicide cases versus other cases. And you can see there's a steady increase all except for 2012 where there's a small dip because there's fewer capital cases overall in the system. But there's been a roughly doubling effect of criminal defendants coming in to the criminal courtroom arguing that their brain made them do it. And they're making all sorts of claims. This chart just shows you the nature of the kinds of arguments they're making, but they're making arguments that range from things like, it was my mental state, which was impulsive, you can see that in my brain. A really interesting one to me is that many prosecutors have already picked up on this evidence. What I've circled here is aggravation. That is, prosecutors have wised up. What does it mean for a criminal defendant to come into the courtroom and say, my brain made me do it and I have no control over it? Is that really mitigating and comforting to a criminal jury? Or instead, is a criminal jury going to look at that person as a programmed individual, unable to control their impulses, likely to recidivate, and likely to commit future crimes? Most likely the latter, in which case a lot of prosecutors have taken this evidence and turned it on defendants, increasingly so over time. That brings me to the third area, and the one in which criminal prosecutors have really focused on, which is predicting future selves. This isn't always a positive thing. We may be able to predict future selves, like if we see plaques in the brain, the probability of developing Alzheimer's over time. But we also are already using predictions from neuroscience to try to figure out the likelihood of recidivism by a criminal defendant. So just as a criminal defendant can introduce evidence during a criminal case to say my brain made me do it, a prosecutor, after a criminal defendant has served a crime, has served his time for a crime, can use evidence for civil commitment purposes. So particularly for sexually violent predators, one of the bases for civilly committing a sexually violent predator is that they have a neurological or biological reason for their likelihood of recidivating. So the very same evidence that's used at trial is now used by prosecutors in order to show the likelihood of future dangerousness of somebody who's already served their time. They then can be civilly committed indefinitely. But also in the context of health and recovery. For example, the impact that recent research might have on our definitions of consciousness and death. Actually, I have 8 minutes. I'm timing it. Yeah. But thank you. So that's what my timer's for, so you can't take my time away. But recent research has had really interesting implications for concepts of consciousness and death. This is an area that we could talk about as an entire conference, but it's interesting to see that people who we previously thought were in a persistent vegetative state, some neuroimaging has suggested to us that some of them have locked-in syndrome rather than being in a persistent vegetative state. That has significant implications not just for how we think about death and benefits, but also how we think about concepts like where life begins, something we can talk about in questions and answers. But this is already being used in the context of threat assessment. So there's a company in Israel called We See You, and they claim that they can integrate into airport kiosks the ability of doing biometric analysis of threat detection of individuals. They claim that they can put subliminal imaging or using intentional masking types of technologies. They can put images of something like a bomb or something like a terrorist photograph, and then they can measure microfacial changes in your face to figure out whether or not you react to that kind of information. Likewise, there are a number of companies, including WeSeeU, that claim that they're starting to be able to do remote EEG detection as well. There's a significant amount of noise in order to be able to do so. The very idea that you can do so and incorporate this information gets back to the very concept of what are we going to do with all of this information that we're storing, and how good are our predictions, will they need to be before we start to use them in issues like threat detection and issues like national security. So that brings me to the last concept, which is continuity of self. So we have to be careful because autonomy, self, and personality might be quite fragile concepts. As we imagine the panoply of treatments that may be available, it's easy to envision that the treatment of individuals with diseases or for any other reason can fundamentally alter the brain. Consider just a couple of examples. One of them, for example, is that researchers at the Fred Hutchinson Cancer Research Center examined dozens of women's brains on autopsy and discovered that the majority of them contained genetic material found only on the Y chromosome. And this was through the simple process of pregnancy with a male child. It seemed like genetic material could end up integrating into and even potentially impacting the brain. Consider how such hormonal differences can affect a person's definition of self, their continuity of self over time, and autonomy. Do these foreign DNA cells have any meaningful impact on the body? Does it change how we think about differences between male and female and more? And what if the intervention isn't a natural one or a consented to one? More controversially, consider treatments that are intended to and designed to interrupt the expected progression of the continuous self. Take, for example, the use of a class of drugs called beta blockers that hold significant promise and peril for treating individuals who suffer from traumatic experiences. The memory itself is not eliminated, but the fear that's associated with the memory may be. So consider this example. If a rape victim goes to a hospital in the first 24 hours after suffering from a sexual assault, she could be offered a dose of propranolol, a beta blocker, that will prevent a consolidation of fear memories. She would be unlikely to develop the post-traumatic stress disorder that might result. But would then she make a reliable witness in a criminal case? What implications would this have for the concepts of continuity and self? Would it matter as a society for if we no longer preserve the fear memories associated with traumatic events? How would that change our conception of harms like rape? How would it change our understanding of traumatic events that occur in the world? And of course, there are new technologies through the BRAIN initiative that are being developed. Some technologies have already reached the hands of consumers, like transcranial direct current stimulation is already being sold direct to consumers as a video gaming device in order to enhance people's perceptual ability to detect different cues and different targets on the screen. But of course, people aren't using this for that purpose alone. They're using it to try to enhance their learning, to speed the rate of information that they're able to acquire and assimilate. And yet, if we increase activity in one area of the brain, what does that do to activity in different areas of the brain? And what implications does that have when parents start to use this technology on the developing brains of children in order to enhance their education and increase their opportunities? Now, of course, they already do so with areas like Ritalin and ADD drugs. Parents tend to be the greatest abusers of actually seeking those types of medications for a competitive edge for their children. But what happens when the technologies become so commonplace that it's easy to override or ignore the concepts of consent with children? And it raises for us complex questions about whether or not we should be able to bind our future selves, and even if we can forecast what our preferences of our future selves would be. Behavioral scientists say that people are terrible at anticipating how we'll adapt to new situations, so this notion of effective forecasting is incredibly problematic when we start to think about implementing things like advanced directives to bind our future selves for treatment for conditions like Alzheimer's disease or schizophrenia or other types of mental diseases or breaks. So in conclusion, there are a tremendous number of interesting implications for concepts of self that are implicated by emerging cognitive neuroscience, some of which the BRAIN initiative will simply aggregate and make more significant. These complex issues raise questions for law and policy about concepts of self and privacy. They raise the fundamental distinctions between issues around autonomy and paternalism, particularly as we think about the regulations of these types of concepts. And it raises for us questions about personal responsibility and agency, and whether or not the fundamental reasons why we hold people responsible in law are ones that will persist as we gain a better understanding of the